Hi, this is a short video on arc length. Our learning intentions are that you will understand what an arc is, understand how to calculate arc length, understand where the arc length formula comes from, practice using the arc length formula, and prior knowledge needed is how to calculate the circumference of a circle. In case you've forgotten, the circumference of a circle is 2 pi r, where r is the radius of the circle, and see there, circumference, which is all the way around. Okay, so to start off we need to define what an arc is. Now we have here a circle with the centre here, two radiuses coming off, or radii coming off there. There's an angle in the middle, and there's an arc here. So this is our angle theta, this is our radius r, and this is our arc. Usually given by either an S, or on your formula sheets you'll find that it is a D, like a large D. So we'll use D for now. Now what we actually say is that officially this angle is subtended by this arc at that point, but really all you need to know is that this is the arc, and we're interested in working out what the length of it is. You'll see why in a few minutes. So it's easiest to see this, I think, if we look at a practical example. So say this is 25 degrees and this is 2.3 meters. Now given that I've said the circumference is going to be important and that we're going to try and work out what D is here, pause the video and see if you can puzzle it out. Can you figure out how to work out that length from the information we've got there? We'll check back in a couple of minutes. Okay, so hopefully you've managed to figure something out. The key to solving this is to see that that distance D here out of the whole circle is the same proportion as this angle is here out of the whole amount of turn in the circle there. And what that means is that D out of all the way around, which is 2 pi r, is equal to our angle here, 25, out of 360, because it's 360 all the way around. If we just rearrange that, we can get our distance D is 2 pi r is 2.3 times 25 out of 360. So I've just substituted in the radius there. And what I did was I multiplied both sides by 2 pi r, so it cancels out here and it multiplies here. So 2 pi times r times 25 over 360. Now, you should be able to work that out. And I got, interestingly, 1 to 2 decimal places. So it's 1.00 to 2 decimal places. So can we work this out then for any arc length, for any circle? The answer is yes. And you should be able to see now that the general formula is going to come from theta out of 360 being the same as D out of the whole circle. So 2 pi r. If we rearrange that again, so just multiply both sides by 2 pi r, and it times is here, cancels out here, and we get D is 2 pi r times theta over 360. On your formula sheets it's written like this, which is exactly the same thing. Sorry, so we haven't got the times, but it means the same thing there. The whole thing divided by 360. So these are identical, and this is the formula that's on your formula sheet. So let's practice using it. If D equals 2 pi r theta over 360, and this is 21 degrees, and this is 6371 kilometers. Can you work out what that distance is there in kilometers? So pause the video, have a go, and check back in a minute. Okay, so this is just a matter of substituting in the values. It's 2 pi 6371 times 21 all out of 360. If we do that over here, we get 2 times pi times 6371 times 21 divided by 360, and I get 2335.09 kilometers. Now, you may think it odd, or may not have thought it odd at all, that I picked this value here, 6,371 kilometers. Well, now I picked that value because the radius of the Earth is approximately 6,371 kilometers. So wherever you see this big R here on your formula sheet, it's referring to this value here, 6,371. So, although this formula works for any size circle where little r is the radius of the circle, this big R here refers to the number 6,371, which is also given on your formula sheet and is the approximate, as I said, radius of the Earth. What that means is you've just calculated, the distance if you were to start at this point and travel, say, due south along the Earth's surface down to this point here, which is of course a curved surface, you would have travelled 2,335.09 kilometres, and that's what we're doing a lot more of, this sort of stuff in Earth geometry. Okay, quick recap then. Circumference of a circle is 2 pi r. The distance formula for the arc length of a circle is 2 pi r times theta over 360. On your formula sheet it uses a capital R, big R, and that refers to 6,371 kilometers, which is the approximate radius of the Earth. Okay, that's it.